Hello and welcome to your lesson on hydrocarbons. So the word hydrocarbon comes from hydrogen and carbon, and literally the word hydrocarbon means it's a substance that only contains hydrogen and carbon, and you need to know that the word there only is important. So many substances contain hydrogen and carbon. Hydrocarbons contain only hydrogen and carbon. Okay, so there's your definition there, only hydrogen and carbon. Okay, so for example here, the first one, CH4, that's a hydrocarbon. C6H18, that's a hydrocarbon. But C4O2H8 is not a hydrocarbon because it has that oxygen in it, so it's not only hydrogen and carbon. So we tend to write or show hydrocarbons in two ways. We either write the molecular formula, which is literally the recipe, if you will, the formula for making that chemical, so CH4, or we draw what's called the displayed formula, and it looks something like this. Each of those lines representing a covalent bond. But you can see here, these are still the same chemical here, so I've got C, 1C and 4H, so this is the same thing. These are both methane. Okay, so pause the video and tell me which one of these is a hydrocarbon. Okay, so A is a hydrocarbon, B is not a hydrocarbon, it's got the chlorine there. C is a hydrocarbon, D is not a hydrocarbon, it's got the little O there. And E is a very funny looking one, but it is indeed a hydrocarbon. So why do hydrocarbons look the way they do, and why can we make such small or much bigger structures? Well, it's all to do with the carbon. So we know carbon's group 4 of the periodic table. It's got 4 electrons in the outer energy level, and that means it has 4 available spaces to fill up to make it stable. So I've got 1, 2, 3, 4. It needs 8 in order to be stable, so it needs another 4 electrons. So it will share, because it's a non-metal, it will share with the hydrogen to make covalent bonds. And this is why, so if we had a carbon here, I would show these lines here showing those 4 covalent bonds that it will make with the hydrogen. Okay, so if they're full up, then it's a stable carbon. Okay, and those lines there represent the covalent bond because we're talking about 2 non-metals. Okay, so in hydrocarbons, these extra electrons then, they don't come from carbon, they come from hydrogen. So here we are, we've seen this already, this is methane. So each hydrogen wants to share 1 electron, and so 4 hydrogens, each sharing 1 electron with the carbon to make this stable structure. Okay, and if you've forgotten this, go back and watch the video on covalent bonding. This one, however, you'll notice here it's shown with another carbon, but each carbon has 4 bonds. So this carbon here, 1, 2, 3, 4, and this carbon here, 1, 2, 3, 4. So the carbon's got to have 4 bonds, otherwise it's not stable. This one here is slightly different. This is what's called a double bond. So, but if you think about each line as a bond, this carbon here, 1, 2, 3, 4 bonds, and this carbon here, 1, 2, 3, 4 bonds. So this is actually still stable. So you can have double bonds. You can actually have triple bonds as well, but we don't learn about them at GCSE. Okay, so we need to know about single covalent bonds. So we don't need to look at the double bonds. We don't need to really know how to calculate them, but we do need to know that hydrocarbons with the single bonds belong to a group of hydrocarbons called the alkanes. So the alkanes is a massive group of hydrocarbons, but all of them have a single bond. And the general formula for calculating alkanes is in that green box there, CnH2n plus 2. I'll come back to that in a second, but N means whatever the number of carbons. For hydrogens, you double it and then you add 2 to figure out how many hydrogens you've got. So how do we work this out then? So let's look at methane, which is the smallest alkane. Okay, so why is it called methane? Well, meth means 1, so there's only 1 of me, and ane means that you have a single bond here. And if you look at that general formula, CnH2n plus 2, so I've got C1, So if I was going to calculate that, so H is double the 1, so that's 2, plus 2 makes 4, 1, 2, 3, 4, so CH4. Okay, so ethane. Why ethane? Why is it called ethane? Well, eth means 2 carbons, and the ane means it's all single bonds. So you draw it like this. And again, that formula works, doesn't it? I've got 2 carbons, so I double them and add 2 to get the hydrogens. So double 2 is 4, add 2 is 6. This is CH6, and that's correct. For propane, prop means 3 carbons, and ane means they're single bonds. So you should be able to draw these by recognizing the names are telling you how many carbons you've got, and then you work out how many hydrogens you should have. Butane means 4, and then of course the ane at the end means a single bond. So if you look, all of these are alkanes, and they all end in ane, 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 because they all have single bonds. There's no double bonds anywhere, okay? And then the prefix of the word tells you how many carbons you've got. Now you need to know these 4, meth, eth, prop and bute, 1, 2, 3 and 4. After that it goes into the normal pent for 5, hex for 6, hept for 7, oct for ane, oct for 8. So you would know that from experience. You know, think about your shapes in maths. So a pentagon has 5 sides. Okay, so a bit different, but I'd like you to pause the video and have a go at these questions for me, please. Okay, so first of all then, define hydrocarbons. These are kind of classic questions you're going to be asked on this topic. So what is a hydrocarbon? It is a substance that contains only hydrogen and carbon. Okay, so you might be asked that question just like that, or you might be given an example and said, which one's the hydrocarbon, how do you know? But you need to know that definition. Okay, so what is an alkane? And give its general formula. So an alkane has single covalent bonds, and the general formula you need to know by heart. You will be asked CnH2n plus 2. So whatever number of carbons you've got, you double it and you add 2. Okay, next question. Pent means 5. Write the symbol formula and draw, so that could be molecular formula, and draw the displayed formula of pentane. So pentane, you know it's 5 and you know it's a single bond. So you would use the general formula to figure out that it's C5H12. So why is it 12? Well, I've doubled 5 and added 2. And then to draw it, I would suggest you draw the C's first, the carbons first, with those bonds in between. Make sure you write the bonds, draw the bonds, sorry. That's often something people forget. And then you do hydrogen above, hydrogen below, and then 1 on each end, and you should end up with a 12. Okay, next one then. Predict the formula of a hydrocarbon with 12 carbon atoms. So again, you're using this general formula. If it's C12, what's the H? Well, I'm doubling it and adding 2. So it's going to be 26. So it'd look like that. The challenge then, alkenes have 1 double carbon bond and a general formula of CnH2n. So you're just doubling it. Write the formula of ethene and draw its displayed formula. So eth is 2, and you know it's got a double bond. So, and I can use a formula, so C2, so I'm just doubling it, H4. So C2H4, and I'm going to play around with that until it looks something like that. Okay, we don't need to worry about alkenes and their general formula. It's not on the syllabus, but it's nice to have that comparison. Okay, that is the end of this lesson, guys. I'll see you next time.